All right, for this next example, they want us to know if r is different numbers, when is r to the n going to be convergent? Or in other words, what numbers can r be so that that ends up being convergent? Let's make a little table on this one to figure it out. So if we make a table here, let's have our whatever we're putting in for r here, and then here let's figure out what's the limit then as n goes to infinity of that r value to the n power. What's that going to end up being? Well, let's start off easy. What if r is 0? Okay, so then we'd end up what's the limit as n goes to infinity of 0 to the n power. Well, no matter what number we put in for n, 0 to that number is going to be 0. So this ends up equaling, let's make one more column here. What's the result? This would be 0 and it would be convergent. Let's try another one. What if we put in 1? What if we have 1 as our, so now this is going to be limit as n goes to infinity of 1 to the n. Well, this one's again pretty easy. 1 to any power is going to be 1. So result is that we have a convergent one that would equal 1. Let's go up 1. What if we do 2? Limit as n goes to infinity of 2 to the n. Well, here, if we put in bigger numbers now, our sequence would be like 2, 4, 6, 8, 10, or sorry, no, not that. It'd be 2, 4, 2 to the third power would be 8, 2 to the fourth power is 16. This is doubling each time. What's going to happen with that sequence? That sequence should get very large. That one's going to approach infinity. If you wanted to, you could double check that on a calculator here. Let's do 2 to the n here and graph that result. And oh, my graph's probably not big enough, but you should see, you can see one value here, but you should see that these would keep increasing there. So this one is going to be divergent here. It's just going to keep going bigger, bigger, bigger. All right. What if we did anything? How about 3? What if we did limit as n goes to infinity of 3 to the n? Well, this sequence would be 3, 9, 27, 81. Again, that's going to get very large. So I think anything we pick that keeps bigger than this, we're just going to get one of those divergent ones. Before we start going to negative numbers, what about, let's think fractions. What if our r value is a half? What would happen then? What's the limit as n goes to infinity of 1/2 to the n power? What's that one going to look like? Well, the sequence would be like 1/2. If we did 1/2 squared, 1/2 times 1/2 would be 1/4. If we did 1/2 times 1/2 times 1/2, that would be 1/8, 1/16. Looks like that one is getting smaller, and my guess is that this sequence, as we keep going, is approaching 0. Let's check it out though. Let's graph this one. So if we did 0.5 to the n, what's that graph? So you can see, yes, this one, here's some values here. You can see it is decreasing. So this one is going to go to 0. Let's just check some other fractions out. What if we did like, I don't know, 3/4? What about 3/4? So what's the limit as n approaches infinity of 3/4? Again, the key with this one is that that fraction's smaller than 1. So if we were to do this one, this would be 0.75 here. Let's graph that one. And again, you can see this is going decreasing towards 0. So this result also results in 0. All right, so I think we got a kind of a handle on the positive numbers. What about what about negative numbers here? So a negative value, what if we put in, say, -1? What's the limit as n approaches infinity of -1 to the n? Well, that's one we've seen before. That one's just going to alternate back and forth between 1 and -1. Is that one going to approach anything? No. This one is uh, oscillating, and so we get that one's going to be divergent. So no result there. What if we picked something like, say, -2? What's going to happen? What's the limit as n goes to infinity of -2 to the n? Well, the result of this one, let's see what we get. So if we were put in numbers, the first number would be -2. Next number would be +4. Next number would be -8. Next number would be +16, -32, and so on. So if you were to graph this one, and you could use a calculator, but I'm just going to quick do it out here. What you're going to see is that you're going to get value here, 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 here. And so these values, they're definitely not approaching anything. You got numbers here that are going to kind of keep exponentially growing that way. You got numbers here that are going to exponentially go the other way. That is not going to be approaching anything. This graph, definitely no value here. And so on that, instead I'm just going to put here that this one's not going to work. This one also is not going to work here. These are both divergent ones. So, and I think the same result's going to be if we put any other negative, positive number in there. Let's try though, what about negative fractions here? What if we did like -1/2? What's the limit as n approaches infinity of -1/2 to the n? This is one I think we can do. Remember we looked at ones like this before. This is one of those you could use absolute value to help us do. So what if we did the absolute value of this limit? Well, absolute value of this would end up being, what's the limit as n goes to infinity? That negative part's not going to matter anymore now, because this would just be what's this, and we saw before that this result ends up being 0. And so if the absolute value equals 0, that means this limit also is going to be 0. So same thing if we were to do, say, -3/4, the answer is going to end up being the same thing, because that limit we did before was also 0. So by that absolute value rule, this one's also going to be 0. All right, so let's see if we can summarize now all of this. What have we found? So we got a bunch of these that end up being 0. So when did our result end up converging to 0? Well, anytime we did a limit here, actually I'm going to write this different. Let's summarize. So if our a sub n here equals r to the n, what's our different things that could happen here? Well, anytime we got an r value between, looks like any fraction smaller than 1, whether it's positive or negative, ended up going to 0 here. So any fraction, anytime it was less than 1, or bigger than -1, so those negative fraction values like the ones here, those ones were all convergent. So what we can say here is that so these ones, the result of all these ones are going to be convergent. or converge to 0. So any r, when r is between -1 and 1, it's going to converge to 0. We had one other one that did converge. It was to a different result though. Our other one that converged here was when we did 1. The result ended up being 1. So if r is 1, another result is that it could converge to 1. And then I think any other answer, any other result we got ended up being not convergent or diverging. So if r is either bigger than 1 or less than -1, or another way you can write that is that the absolute value of r, or absolute value of r is greater than 1. So whether r is negative or positive there, then we get a divergent one. It's going to diverge. So if any of these ones where you have something to a power of n, if it's 1, of course, it's just going to be 1. If it's any fraction that's less than 1, whether positive or negative, it should converge to 0. If that number is any number bigger than 1, whether positive or negative, then it's going to diverge.